Good morning, friends. In the picture, we can see Bakaspur traction substation. It is single phase 25 kV. I have never worked in 20 to 25 kV, but I know the theory. So, if we convert it into 20 to 25 kV system, what we can do? The first facility is our power supply system always has 100% standby. This is a big facility because you can modify one way and then another way. It is after charging this you can do the work on other way. But in 20 to 25 kV system we are using three phases. So first arrange the incoming system changes. We need three phases. Okay. For Scott connection and open delta connections. For Scott connection and open delta connection, we need three phases. First, you arrange it, and for example, you use the two phases. Don't use one phase. Here we have used blue and red phase. So we need yellow phase to arrange. Actually, in incoming side we are taking three phases and one is anchored and terminated. So most of the TSS we are having availability of three phases because our transmission line is three phase. So it will not be a critical one. Next, the equipments in the incoming side. One by one you can replace it because bus coupler isolator is there, double pole. You open it, you isolate it, and also open the bipolar double pole isolator of the one way. So no question of any breakdown or accident. Okay. Now you can replace one transformer. It may be Scott, it may be open delta system transformer, or it may be three single phase transformer. Not two single phase transformer is also can be used for 20 to 25 kV. But better to avoid it, or you can also do it. If you use this single phase transformer 20 to 25 single phase transformer, then you don't need the third way. For delta connection you need third way, but for Scott connection you don't need it, but for open delta you need it. Third way is required. It will be complicated. Better to use Scott connection or three. If you use two single phase transformer 20 to 25 kV, then also it will be simplified. I am telling from my theoretical experience in single phase 25 kV what we can do. Don't take it seriously. This simple give an idea, or I am analyzing it. How can we do it? So first replace one way, replace the power transformer in one way, the equipments, but keep the outgoing of the transformer side in open condition. Double pole isolator and CB will be in open condition. All will be replaced with the system, and all the circuit breaker and everything will be double pole type. Okay. So you have to change this system. First you do in one way, but how to give power supply? You can do one thing. You know PTFE is installed in front of the TSS. So we can take one sector PTFE to PTFE means TSS to next SP. The OHU will require replacement and not replacement with modification. Modification of OHU of 20 to 25 kb in one sector. Then what will happen? You can charge one bay TSS to neutral section. You can charge TSS to neutral section. You can charge, but one side is 25 kb and one side is 20 to 25 kb. The interrupters in the SP is single pole type, so we cannot extend this feed to 25 kb side. So keep it in this position. Parallelly do the adjacent sector also with the same system, so that alternately we can extend feed during power failure. Adjacent sector and this sector you first arrange to modify both OHE and substation, so that we can share the feed extension between these two sectors. If any one is failed, then another can be extended. Now, after arranging this, now we can take another bay and the next subsector also. Again you take these two things, okay, so that again you can do it, but it is not so easy, which is in my opinion. I have to see it in the practical field where this system is in progress. I talk to Eastern Railway what they are doing, but I have thought in this way: take sector at consecutive two sector from one TSS to another TSS, and as 100% standby is here, change one sector and consecutive another sector, both in OHE and both in power supply system. But with this thing, you have to modify the SP of the adjacent two sector. You have to modify the SP and SSP, SSP, and then again another. It will, the normal system is TSS, then SSP, then SP. For next TSS, it will also be SSP and SP. If this system is there, then no problem. But if more than one SSP, more SSP is there, you have to modify all these SSPs step by step, and when it will be modified, then you can arrange power supply for the two consecutive sector of other TSS, adjacent TSS, not other TSS, adjacent TSS. The same way you can proceed for the other two sectors. I think so, but after consultation of the Eastern Railway system, I can assure you. And in OHU, what you have to do, you draw the feeder wire. Change all isolator with double pole isolator. Change the yard line with single pole isolator is okay, no problem, but any changes is required for this yard feeding, you check it. And if siding is there, you put PTFE neutral section in the siding to feed it. long siding. That means private siding. I want to say private siding. For feeding private siding, better to use PTFE. Then what you can do? The CT-PT ratio all will be changed. Circuit breaker and interrupter and all these isolator is of double pole type. Okay, so all are double pole type. So this is the basic idea. This is the basic idea. The facility which you are having and what is the difficulties we have to face. That is the main two things. So in PSI power supply installation we have the facility of 100% standby in the TSS. But in SSP you need so many modification. SSP and SP you need maximum modification because their system is separate. Their system is separate. Some are without bridging interrupter. They are using double pole isolator on both the line, both the main line. Our modification is for only main line. Main line is need the 20 to 25 kV. So this is the simple idea. Just an introduction today, and now I talk to my friends who are already doing this existing system, and then I can assure you. Okay, thank you. Bye. Friends, I have talked what the project is running in Eastern Railway and Southeastern Railway, but they are replacing all the TSS. That means they are installing new TSS, new SP, new SSP. All will be new, and it's include huge amount of money. But what I have thought, it is my own idea, but don't know what problem they will face. Here I have shown the connection of a Scott connected 20-25 kV transformer. In a traction substation, number of Scott connected transformer will be 2. And in our old system also there are 2 transformers. If I install one transformer, Scott connected transformer, and one end is kept idle, one end 20 output is kept idle, and other end is charged. But it needs, it is what? It needs, here is also it is two-way, but auto transformer needs to be connected. Auto transformer needs to be connected. If I modify one bay and another bay also need some correction because auto transformer will be there. If I connect the auto transformer, mid-tapped auto transformer in the second bay auto transformer, if I kept it open circuit, the on the top bay, if I kept it open circuit, without load, it is in idle. Is it not possible? Then the cost may be reduced appreciably. Appreciably the cost will be reduced. But they are installing all new TSS and switching posts. Then the work will be somewhat easier, but cost will be havoc because you have to purchase the land for the TSS and other extra installation, because in TSS, old TSS, no parts will be in use. Probably because bus bar size is not adequate if then because the power transformer rating is more than the traction transformer. Now we are using 30 by 42 MVA transformer in Southeastern Railway, but here it is 54 MVA. So bus bar size, but I think one by one if we replace the standby portion and feed only one end, that means suppose here in the left side we have given power and in the next TSS also the right side will feed the power, then is it possible? That is the question. Okay, when they will replace all the TSS, then the conversion will not be a big thing. Only the OHE mainline feeder wire will to be drawn, 80 post to be installed. 80 post also with this SP, SSP, TSS, 80 post will also be installed only to connect the OHE, So it will be simpler, but cost will be too much. But if I replace with Scott connected V connect open delta connected is not possible because there are 3 bays. But in our system we are having 2 bays. 25 kV single phase 2 bays. You also think for it. If I replace the Scott connected transformer, the top transformer will be need to be idle, will be kept idle. Then it is possible. We need 2 transformers, Scott connected transformer, 54 MVA each, 100% standby. Okay, I think you can understand it now. In the TSS we are having 25 kV 2 bays and 100% standby, means 2 transformers, 1 transformer 1 bay we can modify with 25 kV, but we will keep idle another 20-25 kV because Scott connected is giving 220-25 kV. One will be kept idle, another you can charge. And after that another transformer will be installed, then no problem. Okay friends, you also think, and if you can give me some feedback, it will be helpful. Is it possible to replace one transformer per transformer in single phase 25 kV system with Scott connected transformer one by one? 2 transformers are required. One by one if I replace, what will be the constraint? If anybody can tell, I'll be happy and give me feedback. Okay, today up to this. Next I have to think and also to consult some experienced person. Then let's see what can be done.